Welcome to our first 1.1 video on conditional statements. Our essential question is, how do if-then statements describe mathematical relationships? For the next section, there's going to be a lot of vocab. I suggest that you listen to my explanation of the vocab and then pause and fill in the blanks and write in the missing pieces. Okay. Our first vocab definition is a conditional or a conditional statement. A conditional statement is an if-then statement. So if you clean your room, then you get to go to your friends, or if you are in school, then it is a weekday. And we use this P implies Q notation. That arrow we say is implies. So P would be, well, actually we'll get into that. The next definition is the hypothesis. The hypothesis is the part of the conditional statement that follows the if. So P, that's the first part. So if you are in school, you are in school, that's the hypothesis. Then the conclusion, the part of a conditional statement that follows the then. So Q in the notation, and after the then in this statement is, it is a weekday. The converse is a type of conditional statement, and it is the reverse of the hypothesis and the conclusion of a conditional statement. So if your original statement is, if you are in school, then it is a weekday, you flip those around, you switch P and Q, and you say, if it is a weekday, then you are in school. You'll notice that in the conditional, if you are in school, then it is a weekday, is generally true if you don't think about extracurriculars, but just basics classes. But the reverse, the converse, is false. Just because it's a weekday does not mean you're in school. It could be a holiday, it could be summer. So they won't always have the same kind of what we call truth value. And a truth value is whether a given statement is true or false. So 2 plus 2 equals 4, that would be true. 2 plus 2 equals 5, that's false. Just like our conditional was true, but our converse was false. The negation has the opposite meaning of the original statement. And we've got a couple different types of notations. We're going to use this notation where we use a curly little thing there. We call it a tilde, tilde P. Sometimes you'll see in other books P with an apostrophe or a line over it. They all just tell you to do not that. So the negation of P, or actually this would be the negation of Q, is that it is not a weekday. So instead of the original statement, it is a weekday, it is not a weekday. Inverse is when we negate both the hypothesis and the conclusion. So our original statement is, if you are in school, then it is a weekday. Our negation is, if you are not in school, then it is not a weekday. Last vocab term, the contrapositive says you take the reverse and you negate the hypothesis and the conclusion. So we flip it around. Essentially what we're doing is we're negating the converse. So I'm taking the converse and I'm negating each of those pieces. So if it is not a weekday, then you are not in school. Okay. I suggest that you pause the video if you haven't already to fill in the missing pieces of your notes. Okay. Assuming you've paused and filled in the vocab, we'll keep going. Below, we're not going to take too much time with it, but this is a truth table. It's got a lot of information in it. We're not going to actually assess you on truth tables, but this is something you could see, again, if you take any higher level math classes. So a truth table just helps you evaluate whether a given statement is true or false. So here we've got a general hypothesis and conclusion, P and Q, and we've said, hey, what happens if the hypothesis is true and the conclusion is true? Well, if two things are both true, your conditional statement will also be true. If you start with a true statement and you conclude a false statement, that will be false. You can't start with something true and end with something false. But anytime you start with something false, whether you conclude that it's true or false, that statement will be true. Kind of funny. So these are the truth values for the conditional. If we switch the order, the two top and bottom ones stay the same. True. If we flip them, it's still true implies true, and if we flip these, it's still false implies false. So those truth values stay the same. But when we flip this, false comes first and true comes second. Let's see. So that is true. And if we flip this one, true comes first and false comes second, so that becomes false, because we can't start with something true and imply something false. Then we negate them. So when we negate a truth value, it just changes to be the opposite. So if P was true, now it's going to be false. If it was false, now it's going to be true. That's how we get these two. And then we just use these two columns to help us do this process again. Again, not something that you're going to be assessed on, but just something we wanted to show you. Okay, now let's do some examples. Example 1 says identify the hypothesis and conclusion. If two lines are parallel, then the lines are coplanar. So the hypothesis is the first part. That comes after the if. Two lines are parallel. Those two vertical lines are, remember, our notation for parallel. And then conclusion comes after the then. The lines are coplanar. You can pause the video now and work on this try now 1. Okay. Assuming you've paused the video, this one says, if y minus 3 equals 5, then y equals 8. So hypothesis comes after the if, y minus 3 equals 5, and the conclusion comes after the then, y equals 8. Excuse me. Now, try now B, try this one. So for this one, we're writing it as a if-then. So a rectangle has 4 angles. I can write as if a polygon is a rectangle, then it has 4 right angles. Notice I added the polygon. Sometimes when you switch between types of if-then statements, or you're writing a statement that isn't an if-then as an if-then, you kind of need to add a subject or switch the subject around. So originally it was a rectangle has 4 angles, but it's really that if you're a rectangle, then you have 4 right angles, but I'm not going to refer to the shape as U, so I'm going to call it its mathematical name. I'm going to say polygon. So that's okay to add that word in there. Again, here with this one, a tiger is an animal. This one was kind of tricky. I just wrote, if something is a tiger, then it is an animal, right? We could also switch either of these around. We could say if a polygon has 4 right angles, then it is a rectangle. That won't necessarily be true. We could have a polygon with 4 right angles, but maybe it has more than 4 sides. But would have been a correct if then. We also could have said, if something is an animal, then it is a tiger. Again, that one is false. There are animals that are not tigers, but it still would be an if-then statement. So for the purpose of this question, would be a correct answer. Okay, counterexamples. Counterexamples are examples that show that a statement or a conjecture to be false. So let's look at some counterexamples. So it says, find a counterexample to show the conditional statement below is false. So the conditional statement is if x squared is greater than 0, then x is greater than 0. And I said that x equals -1 is a counterexample. Because if I plug in -1 in for x, I get -1 squared, which is greater than 0, because -1 squared is 1, which is greater than 0. But -1, if I look at the second part, is not greater than 0. Let's look at another example. Let's look at the try now. This counterexample, if it is not a weekday, then it is Sunday. Our simple counterexample is, then it is Saturday. Our simple example is, it's Sunday, right? Sunday is not Saturday, but it's also not a weekday. And last one, if you live in Minnesota, then you live in Inver Grove Heights. Not true. Lots of other places you could live in Minnesota. But we'll just give one specific counterexample. You could also live in St. Paul. You could also say a lot of other cities in St. Cloud, or in Minnesota, such as St. Cloud. Write the converse of the following conditional statement. So remember, converse is the reverse of the conditional. So that's where we switch the hypothesis and the conclusion. So if x equals 9, then x plus 3 equals 12. That's our original conditional statement. So our hypothesis is x equals 9, and our conclusion is x plus 3 equals 12. In the converse, those are going to flip spots, and then we can write our final converse. If x plus 3 equals 12, then x equals 9. Okay. Example 4, write the converse of the conditional, then determine the truth value of each. So if a squared equals 25, then a equals 5. So converse, we flip it around. So a equals 5 is going to go first, and a squared equals 25 is going to go second. If a equals 5, then a squared equals 25. And this is true because if we plug in a equals 5 into a squared equals 25, 5 squared does equal 25. So that is in fact true. Okay. Next, try now. You can pause your video, try this try now on your own, and then we'll go through it in a second. Okay, let's keep going. If two lines do not intersect, then they are parallel. So we want to determine the truth value. So this is not actually true because they could be skew. Skew lines do not intersect, but they are not necessarily parallel, or they are not parallel. Next, we'll find the converse. If two lines are parallel, then they do not intersect. That's true. Parallel lines do not intersect, and we know that by the definition of parallel. Okay, try now B. Take a second and try this one. Okay. So first, if x equals 2, then the absolute value of x does equal 2. That's true. The absolute value of 2 is 2, so that fits. The converse, we flip them around. If the absolute value of x equals 2, then x equals 2. This is false, and it's because if x equals negative 2, the absolute value of negative 2 also equals 2. So that's not necessarily true. We found a counterexample. Okay, example 5. Write statements with all, some, or no to describe the Venn diagram. So here's our Venn diagram. Our all statements. So here we see that we've got jazz band students, and choir students. Some choir students are band students. There's some overlap there. All jazz band students are band students, but no jazz band students are choir students. So I've written those down here. All band musicians are in band, right? That whole jazz band circle is completely encompassed by the band circle, so they're all band students. There's some overlap between choir and band, so we say some choir musicians are in band, but there's no overlap between the jazz band circle and the choir circle, so no jazz band musicians are in choir. Okay. Example 6. Write the negation of each of the following statements. So, if A, B, C, D is not a convex polygon, there's already a not in there. To negate the not, we simply take it away. They undo each other. So we can say ABC is a convex polygon. This one, the measure of angle XYZ is greater than 70. Instead of being greater than 70, it's going to be less than or equal to 70. That is the opposite. So for inequalities, to find the opposite, to negate, you always flip the inequality, and then if it doesn't have a or equal to part of it, you add it, and if it does, you take it away. And then lastly, today is Tuesday simply negates to today is not Tuesday. Okay, getting close to the end. Example 7, write the inverse and contrapositive of the conditional statements below. So first, I have my conditional. If triangle ABC is equilateral, then it is isosceles. We've labeled the hypothesis and conclusion. If I want to find the inverse, I negate both of those. So if triangle ABC isn't equilateral, then it isn't isosceles. And then to find the contrapositive, I simply switch the order up. So I say, if the triangle ABC isn't isosceles, then it isn't equilateral. Notice triangle ABC is our subject. When I wrote the contrapositive, I still put the subject in the first part. That way the sentence just reads well. It makes sense if you read it as an English sentence. If we had left it in the second part of the sentence, it would be a really confusing sentence to read. So it's okay to move the subject around so that you can actually read it. Okay, got just a couple more examples and then we're done. Or actually, I think it's just a try now. So you can work on this try now. You are going to write the converse, inverse, contrapositive for each of the statements and determine the truth value. So the statement that you're going to do that for is, if two segments are congruent, then they have the same length. That is true. So pause the video, try that. Okay. So we can say the converse switches the order. If two segments have the same length, then they are congruent. That is true. The inverse negates each of them, but leaves the order the same as the original. If two segments aren't congruent, then they aren't the same length. That is true. And then the converse switches the order of the inverse. So if two segments aren't the same length, then they aren't congruent, and that is also true. Last one, you can pause this try now as well. Okay. If you do not work, then you do not get paid. That is true. If you're not going to work, you're not getting paid. If you get money and you're not working, I would say that's a gift, not payment. Converse, if you don't get paid, then you don't work. I would say that's false. There's volunteer work where you work, but you don't get paid. Inverse. Oh, did I flip those around? Oh, no, I didn't. Inverse. If you do work, then you get paid. Again, volunteer work would be a counterexample. Contrapositive. If you get paid, then you work. I would say that is true. Okay, that is the end of our first 1.1 video. Watch for the second video next.